So I have given you a worksheet, and we're going to be talking about what are called key features. And key features they're actually pretty simple, but kids get confused on whether we're talking about x's or whether we're talking about y values. So let's look at the first one. All right. So for this first one, we have a bunch of different things we need to list about this particular parabola. And I have graphed the parabola for you. But I want you to go down and state whether the value is an x or a y. So this one is an x. This one is a y. This one is an x comma y. This one is an x. Range is a y. And then the other four are all x's. And that tells you which axis to read. And notice, there are only 3 y's on that whole list. The y-intercept is a y. The range is made up of y values. And then there is an x or a y component in the minimum or the maximum point. Everything else is x's. And a lot of times, especially on these bottom 4, it's very common for kids to make a mistake and put y values in there. Okay? So the first question is x-intercepts. Where does that graph hit the x-axis? So x is equal to -2 and 4. Or -1. Sorry. Last time I listened to you. Okay, -1 and 4. Everybody all right with that? What about y-intercepts? So y is equal to -4. Does this one have a maximum or a minimum? It has a minimum, so let's circle minimum. And where does that minimum take place? 1.5, comma, -6.25. Now, I want you to notice, this answer has parentheses around it, and this answer does not. Why? Right. So, we have to distinguish between, are we talking about one number on an axis, or are we talking about a position that contains an x and a y? Okay. What's that? Okay. Now, domain. This is where it gets a little bit confusing. The domain wants to know, what are all x values? Can you list every single x value that shows up on the graph? So, is there an x value for x equals 3? Is there a point on the graph that is 3 comma something? Yes, it would be right here. Okay. What about -3? Where is it? It's way up high, so it's going to be like right there. What about 8? There will be one for 8. It's just way the heck up there. You're close. So here's how we handle the domain. We draw a vertical line, and then we move that line back and forth. Now, if this line goes forever in both directions, will it ever miss the graph? No. Okay? Which means -10 has a point on the graph. We can't see it because it's way, way up there. But -10 does have a point. And it doesn't matter how far I go over here, every single one of these lines will hit the graph. So the answer to the domain is everything. The whole x-axis. And here's how we write it. we say x equals, and then we use this R symbol that has two lines on the left. And that is the mathematical symbol for every single real number. Do you guys understand that? Now, this might be a little confusing to you because we drew a vertical line, but we were talking about the x-axis. You guys understand why we did that? Because vertical lines hit the x-axis. Horizontal lines, most of them miss the x-axis. Okay, now for the range. We want to do the same thing, but we have to flip the line horizontal. Now, I can't grab it. Does this line, does this line ever miss the graph? Yeah, down here. Okay, all of this, all the way down to negative infinity, misses the graph. Okay, so when you talk about the range, you want to start at the bottom. And we start coming up. And then when do we first hit the graph? Right there, negative 6.25. When do we stop hitting the graph? Never. So to write that, and it's going to be right here, we say that the range, give me a different color. The range is y is equal to every number from, we state the low number to the big number. What is the smallest number that y can equal? Negative 6.25. And what is the biggest number that y can equal? Infinity. Okay. Now, do you guys know the difference between x is greater than 3 and x is greater than or equal to 3? So, if I had a number line, how do I graph x is greater than 3? It's an open circle, and we shade to the right. Do you guys remember this? Okay. And then how do we graph the other one? It's a closed circle, and then we shade to the right. Is negative 6.25 an open circle or a closed circle? Closed. Why? It does exist. Okay? So, one way to write this would be y is greater than or equal to negative 6.25. But we don't do it that way. And I'm not going to get into why. But we choose to use what is called interval notation. An interval notation, you list the small number and you list the big number, and then you put parentheses around the edges. But the parentheses matter. If the point is an open circle, then the parenthesis is just a regular parenthesis. Okay? If that point is a closed circle, then we use square brackets to denote equal to. So negative 6.25 actually gets a square bracket, which tells us that negative 6.25 does count. Okay, and we'll do several problems, and hopefully it will make sense to you. Okay, and then does infinity count? Can we actually reach infinity? No, so we always put open on infinity. That's just how we do it. Okay. Now, here's another place where people get confused. What is the difference between this notation and this notation, other than the bracket? So one is an x comma y, which is a point on the graph. Yeah, the other one says every y value from negative 6.25 up. How do we tell the difference between a point and this is called an interval? And the way you tell is intervals will always have that. or they should. Okay? Because they kind of look the same. So how do you distinguish between a point and an interval? An interval will always say x equals or y equals. Okay. Now for the hard ones. Let's pretend that we're driving our little math car. It's beautiful. Totally beautiful. So I'm driving this. Now we always drive from left to right. Always. Okay? So I'm driving this car. Nope, I'm not making the car bigger. That wasn't the point. So we drive this car, and it's actually tilted downhill. We're going down the hill, down the hill, down the hill, and we get to the bottom of the hill, and then we start driving up the hill. Okay? We always drive the car from left to right. Okay? And we want to distinguish when is the road increasing, which means when are we traveling uphill? Now you have to be careful. Listen to what I said. When are we traveling uphill? Ah, good. Why 1.5? It's the x-axis. I didn't ask, how low did I reach? Right? I want to know when. So this is a graph that shows time on the x-axis and then height on the y-axis. So when did we start driving this car? Forever ago. And how long will we be driving this car? Forever. That's the domain, right? Everything. So if we started forever ago and we end forever from now, at what point will we start going uphill? At 1.5 seconds. So increasing will be x is equal to 1.5. When will I stop going uphill? Never. So that is infinity. Now, do we use parentheses or brackets? Well, we know infinity gets a parenthesis every time. Okay? What happens at 1.5 seconds? I start going up the hill, but at 1.5, am I pointed uphill? No. Which way am I pointed? Flat. So at 0 seconds and 0.5 second and 1 second and 1.4 seconds and 1.49 seconds, the car is tilted down. But at 1.5 seconds, the car is totally flat. So can we say that the car is going uphill at 1.5 seconds? No. So 1.5 seconds does not count, which means it gets, parenthesis. Bracket means equal. Parenthesis means not equal. Okay? So at 1.5 seconds, we are not going uphill. At 1.501, we are going uphill. Does that make sense? Okay. And notice I put the x equals there. That tells us it's not a point, it's an interval. Okay, the next question. When is the road going downhill? Oh, good question. Can we write it the other way? It's always small number, comma, big number. Yeah, it has to be small number, comma, big number. Yeah. So decreasing, that's going downhill. When did we start going downhill? Forever ago. When do we stop going downhill? At 1.5. So this one would be x is equal to negative infinity, comma, 1.5. What symbol do we put on infinity? Parenthesis. Now at 1.5, if 1.5 counts, it gets a bracket. If 1.5 does not count, it gets a parenthesis. So what happens to the car 1.5 seconds from now? It's flat. It's the only spot on the graph where it's flat. So 1.5 does not count. We put a parenthesis. Okay. So I want you to take your colored pencil and so I want you to highlight I don't know how to make this work. I don't have a highlighter. But anyway, highlight this and then highlight this. And then get a different color and highlight decreasing and then highlight decreasing. Won't let me do it. Okay. Now the next question asks, when is the graph positive and when is the graph negative? So imagine you went to Death Valley. Death Valley is below sea level. And you go down a hill into Death Valley and you drive across Death Valley and then you go up out the other side. Sometime during that drive you will be below sea level, and sometime during that drive you will be above sea level. So get another color and highlight positive. Where is the graph positive? This chunk over here and this chunk over here. Oh, good. Yeah, we'll get to that in just a second. Uh-oh. Pick a new color. Highlight negative. When is the graph negative? This piece right here. Okay. So let's write this down. Look at positive. When is the car above the x-axis? When is the car above sea level? Well, we have to look at the x-axis. So we say x equals from forever ago. So negative infinity. And when do we break sea level? At -1. Now notice, we're looking at the y-axis, not the x-axis. The graph is going down, but we want to know when. And the answer is 1 second ago. Now, negative infinity always gets a parenthesis. Is the car above sea level at -1? No. What's happening at -1? It's at sea level. Is 0 a positive number? No. It's not a negative number either. So do we put a parenthesis or a bracket on -1? Parenthesis, because it is not equal. Okay. Is there another point? Yes. So whenever you want to join two sets together, you do this weird looking U. It doesn't have a tail on the one side. That is the math symbol that means we're going to link two intervals together. It's called the union. Okay. You guys know what a Venn diagram is, right? So a Venn diagram looks like this, right? This would be A, this would be B. This little section in here is called A intersect B. That's what A and B have in common. Okay? And then if you wanted to do all of this stuff, all of A and all of B, you say A union B. So there's a whole mathematical language of symbols that they made me learn in really high mathematics, and it was very, very difficult. And union is really the only one you guys are going to see. So whenever you want to link two sets together, you use the union symbol. Okay? When do we come out of the below sea level portion? At 4. Oh, I put a parenthesis there. So 4. And how long do I remain above sea level? Forever. Infinity. So at 4, are we positive? No. Parenthesis. And infinity always gets a parenthesis. We get that? Okay. Now negative. X equals. When is the car below sea level? 1 second ago up to 4 seconds from now. So -1 to 4. Are we below sea level at -1? No. Parenthesis. Are we below sea level at 4? No. Parenthesis. Okay, do you guys understand that? So the biggest mistake people make would be right here, and they say y values instead of x values. All right, let's clear this out. And let's turn this back on. Maybe. It didn't work. There we go. All right, let's do number 2. Okay, and maybe it's a good idea for you to remind yourself x, y, x comma y, x, y, x, 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 x. The only y values are the y-intercept, the y portion of the maximum or minimum, and the range. Everything else is x-axis. Okay. What are the x-intercepts? So x equals 1 comma 4. Do I need to put any symbols around those? No, that's a list of 2 numbers. Okay. The y-intercept is -4. This one has a maximum at 2.25 comma, or sorry, 2.5 comma 2.25. Okay. How did we find the domain? If you hold your pencil vertical and you move it back and forth, does this line ever miss the graph? No. So if every answer is valid, what do we write? The funny little r. So x is equal to the real number symbol. That means every number exists. Okay. For the range, we flip our line sideways, hold our pencil sideways, and then we move it up and down. Does this line ever miss? Yes. So we always start little number to big number, so we go down as far as we can. When do we start hitting? Forever ago. When do we stop hitting? 2.5 or 2.25? The y value, 2.25. That's a very straight line. I did a good job. So the range, y equals -infinity to y equals 2.25. Okay, now we pull out our colored pencils. And we highlight increasing. Where is this graph increasing? When is the car going uphill? The left side. That's when the car is going uphill. Okay. When is that? Now, good, it's from negative infinity to 2.5. But remember, these are x values, not y values. So we're not looking at the bottom of the graph. We're going from the left side up to 2.5. So we write x equals negative infinity to 2.5. Negative infinity gets a parenthesis. What about 2.5? Parenthesis. Oh, shoot, I messed up. This one should be a bracket because the y value does hit 2.25. Okay. Get a different color. Highlight decreasing. Where is the graph decreasing? The right side. Okay. We write x is equal to, when does the car start going down the hill? At 2.5. When does the car stop going down the hill? Forever. So how do we write forever? Is it infinity or is it negative infinity? Which axis are we looking at? X. So the graph is going down to negative infinity, but we're not looking at the y values, we're looking at the x values, which says 2.5 seconds from now the car will start going down the hill, and it will go down the hill forever. Positive. Okay, so we are looking at this here to the right. Yes, the car is going down to negative infinity, but that's a y value. When you look at time, it's positive infinity, and they both get parentheses. Okay. Now highlight positive. When is this graph positive? This section right here is above the x-axis. That's when we are above sea level. When does that start? Nope. X values 1 to 4. So 1 second from now you will drive out of Death Valley. And then 4 seconds from now you're going back into Death Valley, below sea level. So 1 to 4. Parentheses or exponent or brackets? Parentheses on both. Okay. New color. Highlight negative. Okay. When is this graph negative? This left piece and this right piece. And don't forget, we are not looking at y values. We are looking at x values. So what are the x values on the left side? What are the x values here? From forever ago up to 1 second. Okay? So negative infinity is the small number to 1. And they both get parentheses. Then we write the union symbol. How would you describe this chunk? Is it 4 to infinity or is it 4 to negative infinity? We're looking at the x-axis, 4 to infinity. Does that make sense? Okay. You have two graphs on the back side. Look at the fourth one. When is the fourth one positive? Never. When is the fourth one negative? Always? It doesn't cross, but it bounces at -3. So If that is your path that you're driving, do you ever go above sea level? No. Are you ever not below sea level? Yes, at one number, at -3. Okay? All right. Get to work.